Hey guys, it's me. You'll see that I'm on location. If you look behind me, you probably notice that I'm in the classroom. This week, you're going to be watching videos on Newton's laws of motion and experimental design. So, this is called Laws of Motion. Thank you, Sir Isaac. Now let me tell you a little story. You see a picture here with a man that has an apple. This is Sir Isaac Newton. Sir Isaac Newton is responsible for giving us a lot of the information and the studies that we know about for force, motion, and energy. He was actually a mathematician, and he's going to come up again when we start to talk about the universe. But I wanted you to get an idea of who he was and kind of where all of this came from. He's credited, supposedly the little myth is, the apple fell on his head and he figured out about gravity. So we'll come back to Sir Isaac Newton. But what exactly did he do for us? Well, let's talk just for a second. We have 3 laws, and here's the first law. It's called Law of Inertia. Here's what the law states. An object at rest stays at rest. So the objects that are in my classroom right now are going to stay in my classroom from day to day, or the objects in motion are going to stay in motion. So whatever the object is doing, it's going to continue to do that unless acted upon by unbalanced forces, which we've already talked about unbalanced forces. We know that unbalanced forces can cause an object to speed up, we can cause an object to slow down, or it can cause an object to change directions. And here are 2 examples. Riding in a car that suddenly stops. What happens to your body? Well, most of us know that we're going to fly forward. The seatbelt, if you've got it on, is going to hold on to you and keep your body back. Inertia is just simply your body wanting to continue to fly forward because it was already in motion. And the unbalanced force would be the seatbelt. Sitting in the roller coaster, waiting for it to begin, what happens when the ride starts? You know there's always a little jerk when the ride starts with your body. It's because you've been sitting still and an unbalanced force has acted on you. Now I've got an animation for you to kind of give you an example. Here's a picture of a car. And the car, if it drives forward and hits into the wall, then it's going to cause the person to fly forward. So this is the example, the car and the wall. Newton also has a second law of motion. His second law of motion, hold on, I'm having an issue. Oh, there he goes. He's flying. All right, now we're going to hide him. And we're going to go back to his second law of motion. Basically, the second law of motion deals with force, mass, and acceleration. So the amount of force that's required to change an object's motion is directly related to the mass of the object times the rate of acceleration. Now, if I have a bigger object, my mass is greater, we know that we're going to have to apply a lot more force to change that object's motion, and vice versa. Something that's small, has a small mass, requires very little force in order to change the object's motion. So here's 2 examples for you. An 18-wheeler versus a motorcycle, and hitting a tennis ball versus a golf ball with a golf club. At this point, you could pause and answer both of these questions. And here is a picture to kind of get you an idea. We have an elephant. The elephant is falling at the same rate as the tiny little piece, the feather next to it. Gravity is going to have the same pull. We know that from the coins, the coin activity that you guys did. But the elephant is going to make a greater force impact on the ground because the elephant has greater mass. So this is where the law comes into play. And hopefully at this point he's started to move. So I'll let you see that just for a second. You see them falling, and when the elephant gets down to the bottom, it's a big, huge mess. All right, then Newton's third law of motion is going to be action versus reaction. Every action has an equal but opposite reaction. 2 examples, a running back being tackled by a defensive player, and then a rocket launch. Pause this video, look at the question, and answer it in your notebook. And the last piece, here is a little animation for you. We have a rocket launch, and you can see it go up, up, and away. It's pushing down, and the rocket launches upward. And ladies and gentlemen, that's a wrap.